Dwarf planet discovery shakes up Planet 9 theory. A newly discovered dwarf planet located in the outer solar system has been announced. This discovery could potentially impact the ongoing debate surrounding the existence of the hypothetical Planet 9. Now let's get into the story on this AI podcast.
Welcome to the deep dive. You brought us some really fascinating material today. Something about a new discovery way out at the solar system's edge.
That's right. And it might connect to, the big mystery out there, Planet 9.
Ah, okay. Planet 9. Intriguing. So what do we got?
We've got details on a new object found by researchers at the Institute for Advanced Study in Princeton. It's called 2017 OF201.
2017 OF201. Got it.
And our mission, really, for this deep dive is to unpack what this object is, why its orbit is so, weird, and how it feeds into this whole hunt for a possible giant planet way, way out there.
He sounds great. It definitely has that frontier feeling, doesn't it? Extreme orbits, whispers of gravity from something unseen. Okay, let's get into it. Where do we start with this? OF201.
Okay, so the source is identified, as I said, 2017 OF201, discovered by Sihao Cheng, Jax-Wen Lee, and Narites Yang at Princeton, and it's what we call a trans-Neptunian object, a TNO. Basically, its orbit is further out than Neptune's.
Okay, so it's in that really distant region.
Yeah.
But we know about other TNOs. What makes this one special?
Well, two things mainly. Its potential size, it could be a dwarf planet, and crucially, its orbit. It's just extreme. One of the most unusual ones we've found at the edge, really.
Extreme how? And how did they even spot it if it's so far out?
Good question. The team used some pretty advanced computational methods. They were basically sifting through huge amounts of telescope data, looking for faint objects moving in very peculiar ways.
Data mining, essentially.
Exactly. And the orbit calculated for 2017 OF201 just jumped out as something really different.
Okay, you keep saying extreme orbit. Give me the numbers. Just how wild is this path?
Okay, get this. Its aphelion, that's its farthest point from the sun, is over 1,600 astronomical units. 1,600 AU.
Ooh, okay, remind me. 1 AU is Earth-Sun distance.
Yep, and Neptune is only about 30 AU out, so 1,600's incredibly far.
That's mind-bogglingly distant. And it takes how long to go around once?
The estimate is about 25,000 Earth years for one orbit.
25,000 years. Unbelievable. What about its closest point? Does it ever swing nearby?
Nearby is relative. Its perihelion, the closest point, is around 44.5 AU.
Okay, so roughly Pluto's neighborhood at its closest.
Right.
And then it gets flung out more than 50 times farther than Neptune for thousands of years.
Precisely. It's this incredibly wide, stretched out, elliptical path.
And an orbit like that, it doesn't just happen, right? It implies something must have, messed with it.
Exactly. That's the key takeaway. As Narites Yang from the team noted, an orbit this extreme strongly suggests it had some serious gravitational interactions in its past.
Like what?
Like a close encounter with a giant planet. Something massive must have given it a gravitational kick, basically flinging it onto this wild trajectory.
Could that have been, say, Neptune or maybe Jupiter or Saturn way back when the solar system was forming?
It's possible. One idea mentioned by Sihao Cheng is that maybe it got ejected way, way out first, perhaps even towards the Oort cloud.
The Oort cloud, wow.
Yeah, the very edge. And then maybe something else, another gravitational nudge, kind of perturbed it back onto an orbit that brings it just close enough for us to eventually spot it near perihelion.
Okay, so these extreme orbits, these patterns, why is this specific kind of orbit so important for the bigger picture out there?
Because when astronomers started finding more and more of these really distant TNOs with weird orbits, they noticed something odd. Their paths weren't random.
Not random how?
There seemed to be a kind of clustering. The orientations of their orbits, particularly the elongated ones like this, seem to be pointing in roughly similar directions in space. It's like something was shepherding them.
And that's where Planet 9 comes in.
That's exactly where it comes in. The Planet 9 hypothesis, which really took off with Konstantin Batygin and Mike Brown's work in 2016.
Right, I remember that.
It proposes that there's a large, undiscovered planet whose gravity is responsible for shaping these peculiar orbits, for creating this clustering effect.
How large are we talking? Like Earth size?
Potentially much bigger. The models suggest maybe Neptune-sized, possibly up to 10 times Earth's mass.
10 Earth masses. And orbiting where? Way, way out.
Way out. Maybe on average 30 times farther from the sun than Neptune is, taking maybe 10,000 to 20,000 years to go around once.
Okay, similar time frame to this new object's orbit, interestingly.
Yes, that's part of the picture.
But crucially, We haven't actually seen Planet 9, have we? It's all inferred.
Correct. It's entirely inferred from these gravitational effects on the smaller bodies we can see, like 2017 OF201. It's like seeing footprints in the snow and deducing something big walked by. You see the effect, not the cause, directly. At least not yet.
So finding 2017 OF201 with its incredibly long, specific kind of orbit, how does that fit the Planet 9 puzzle? Does it strengthen the case?
It really seems to. Its orbit is exactly the type that fits the pattern Planet 9 is supposed to create. It's another one of these footprints.
Another piece of evidence pointing toward this unseen gravitational influence.
Exactly. It adds more weight to the idea that the orbits of these distant objects aren't just random, that something substantial is likely organizing them.
And the location where they found it, the sources mentioned, was well beyond the main Kuiper belt.
That's right. Finding something potentially this large, this far out, suggests that region, which we used to think was maybe pretty empty beyond the Kuiper belt edge, might actually be more populated, more dynamically interesting than we assumed.
It really drives home how much we still don't know about our own solar system, doesn't it?
Absolutely. And think about this. See how Cheng points out, we've only observed maybe 1% of this object's entire 25,000-year orbit.
Just 1%. We've seen a tiny fraction of its journey.
Yeah. It's kind of mind-bending, you know? We have telescopes peering billions of light years away, seeing the dawn of the universe.
Right.
And yet, right here, just a few hundred or thousand AU away, there are potentially massive planets and whole populations of objects we're only just beginning to uncover. So much still hidden in our own backyard.
So Planet 9 is still a hypothesis, not a proven fact.
Still firmly a hypothesis. But discoveries, like 2017 OF201, are absolutely crucial. They give us the actual data points, the specific orbits that let us test the hypothesis, refine the models.
And build a better picture of how this distant frontier might be structured.
Precisely. Each discovery like this helps us understand if Planet 9, or something like it, is really out there and how it might have shaped the solar system we see today.
It's like this object, 2017 OF201, is a messenger, carrying clues about something huge and unseen in its very path.
That's a great way to put it. Orbital dynamics can tell you so much about the hidden masses in a system.
So wrapping this up, what's the big takeaway for you listening in? Well, think about it. If the tiny, almost imperceptible gravitational pull of a massive planet, maybe 10 times Earth mass but incredibly far away, could be sculpting the 25,000-year journey of an object like 2017 OF201, it just makes you wonder, doesn't it? What other invisible forces, what other hidden objects might be subtly shaping things we observe, things we haven't even thought to question yet? Not just here, but maybe in other star systems too. It's a reminder that there's likely still so much more going on beneath the surface than what we can immediately see.
Could discoveries like this reshape how we define planets and the boundaries of our solar system? Don't forget to comment it. Thanks.